Okay, here we go. Pythagorean triple. A Pythagorean triple is a non-zero whole number that satisfies the equation c squared equals a squared plus b squared. Pythagoras was this Greek guy that lived like over 2,000 years ago. Okay? 400-ish BC, 600-ish BC, whenever. Long time ago. Okay? Now, he was a very revered mathematician and teacher and scholar. And he wrote all kinds of things about math, but there's only one thing that really he's known for today, and that's c squared equals a squared plus b squared, which we'll get to in a second. But Pythagoras was loved by his followers. He had like a cult-like following. I mean, they loved him so much that even after he died, if anybody spoke ill about Pythagoras, well, they'd go jump in a boat, go out to the middle of the Mediterranean Sea, and have people who spoke bad about Pythagoras, they'd throw him right over the side of the boat and drown him. Yeah, they murder people that would speak against Pythagoras. Okay? So, just so you know, don't speak ill about Pythagoras. Something bad could happen to you. All right. So, the Pythagorean theorem is this. The hypotenuse squared of a right triangle is equal to the sum of the squares of the legs. Now, that's kind of complicated in saying, so we made it so much easier. If you make the hypotenuse of a right triangle C and the legs A and B, C squared is equal to A squared plus B squared. Okay? C squared is equal to A squared plus B squared. So let's look at an example of this. Okay? We know that c squared equals a squared plus b squared, and we want to find the hypotenuse of this right triangle if we know one leg is 3 and the other leg is 4. Well, C is C. A, it can be this one up here, or it can be this one down here, but we'll make A the left one, the up and down one for right now, B the bottom one. It doesn't matter which is which, because a leg is a leg, and when you add them up, it really doesn't matter. So, if we go 3 squared plus 4 squared, then c squared equals, what's 3 squared? And 4 squared. So c squared equals 25. Take the square root, c equals 5. That's how to find the third side of a right triangle. You use the Pythagorean theorem. Now, what if we're looking for a number that's not the hypotenuse? Well, we know 13 is what letter? C. 5 is what letter? A or B. It doesn't matter. Let's make it A. And X is B. So 13 squared equals 5 squared plus X squared. What's 13 squared? 5 squared is 25. How do I get X squared alone? Subtract 25. X squared equals 144. If we take the square root of that, x equals 12. Now, will it always be a whole number? No. No, it will not always be a whole number. We'll get to that a little later. Now, the converse of the Pythagorean theorem is going the other direction. Okay? If you have a triangle, is it a right triangle? And if it's not a right triangle, what is it? Acute or obtuse. Because if it's a triangle, what type of a triangle is it? Acute or obtuse. So, here we go. If c squared is equal to a squared plus b squared, we know it's a right triangle, because that's what the Pythagorean theorem tells us. If c squared is less than a squared plus b squared, then it's acute. If c squared is greater than a squared plus b squared, then it's obtuse. Okay? Always make sure you have the C on the left side. Big, obtuse, little, acute. Just like angles. Big angle is obtuse angle, little angles are acute angles. So less than, little, acute, greater than, big, obtuse. All right. So what type of a triangle is a 12, 16, 21? Well, the 21, you make C. The biggest one, you always make C. It's not just the last one, but the biggest one, you always make C. So 21 squared compared to 12 squared plus 16 squared. 21 squared is 441. What's 12 squared? 144. And 16 squared is 256. Okay? So, if we add those together, this is still 441 on this side, but this side is 400. Since this is bigger, 441, not 444. Since this is bigger, then it is an obtuse triangle. Pythagorean triples. If you know your Pythagorean triples, it makes doing geometry a whole lot faster. Okay? Lots and lots and lots faster. So, we've already seen the example where if the legs are 3 and 4, the hypotenuse is 5. Okay? So that makes a right triangle. A right triangle will also be a 6, 8, 10, and 9, 12, 15. Multiples of 3, 4, 5. Because this is 3, 4, 5 times 2. This is 3, 4, 5 times 3. We could take it times 4, times 5, whatever. Okay? We saw a little earlier that we have a 5, 12, 13 triangle that's a right triangle. So if we multiply it by 2, or 3, or 4, that's a Pythagorean triple. Two other Pythagorean triples are 8, 15, 17, and 7, 24, 25. If you know your Pythagorean triples, you can just look at the list and say, oh, I know the answer, and just put the number down without having to do the Pythagorean theorem. Okay? All right. So let's look at some example problems. All right. What is the value of x in simple radical form? 12, 16, x. Well, back on the previous page, there was a Pythagorean triple to help us with that. Okay? But we're not going to look back at it. We're going to actually do the math problem just so we practice at this. So how would we set this up if we know c squared equals a squared plus b squared? What would I put in place of c? X. So x squared equals, what did I put in place of a? 12 squared, and b? 16 squared. So x squared equals 144 plus 256. X squared would equal 400. So if we take the square root of each side, x equals 20. Okay? 8, what? 17. Okay, now we're going to cheat. How are we going to cheat? Well, we're going to look at our Pythagorean triples. 8, what? 17. 15. So if you know your Pythagorean triples, you don't even have to do the math. 5, 12, 13. 13, what? 84? I don't know. You might have to look that up. 15, 20, 25. Because this is just like 3, 4, and 5. Okay? Pythagorean triples. If you know your Pythagorean triples, they work for you. Now, is 5, 12, 13 a Pythagorean triple? Yes, because it satisfies a squared plus b squared equals c squared. Is this a Pythagorean triple? It could be. It's hard to tell, so if we don't know, we say 45 squared, compare it to 27 squared plus 36 squared. Okay, what's 45 squared? Calculator, please. 2025. What's 27 squared? And 36 squared?
1296.
If we add them together, we get 2025 and 2025. They're equal, so yes, it is a Pythagorean triple. Now, what would have made life easier? What number goes into all these? 9. 9. If we divide them all by 9, this is 3, this is 4, this is 5. Is that a Pythagorean triple? Yes. 3, 4, 5 is Pythagorean triple. All right. This problem, it's not going to be a Pythagorean triple. So then what we have to do is do the Pythagorean theorem. If they're not a Pythagorean triple, you got to actually do the Pythagorean theorem here. This is C, this is A, this is B. So 9 squared equals 4 squared plus x squared. 81 equals 16 plus x squared. We subtract 16 from each side. X squared equals, what's 81 minus 16? 65. Does that have a perfect square root? No. Any perfect squares go into it? No. So the answer is just the square root of 65. We leave it like that. Hey, he's not as annoying as what other people have been in this class.
You talking about me?
No.
Okay. Just say it.
No.
My feelings don't get hurt.
I bet your feelings do get hurt.
I mean, they do, but not by teachers.
Oh, okay. Let's look at this one. C squared equals a squared plus b squared. So 19 squared, compare it to a squared plus 16 squared. 19 squared, something with a 1 at the end. 361?
Yeah.
A squared plus 256. Subtract 256. 105. Take the square root. Any perfect square numbers go into 105? Nope. So we're at square root of 105. That's how we leave it. Okay? Now, here's a building. Here's a 13-foot long ladder. It's 8 feet from the wall. How high up the wall are we? No. The ladder's 13 feet, but it goes at an angle. If it was straight up and down, you'd be 13 feet up the wall. But it's at an angle. Whoa.
So 13.
13 squared equals x squared plus 8 squared, right? 169 equals x squared plus 64. So 105 equals x squared. Take the square root of that. That's 10 point what? I don't think so. Square root of 105. To what? It says round to the nearest hundredth. That's 2 decimal places. Are you sure it's 25 or is it 24? So then it's 10.25. Okay? Here's a square. There's a diagonal that goes across it. The diagonal is 12 meters long. How long's the side of the square? We don't know, because 6 plus 6 makes 12. There'd be no way that would work. So, both A and B are x. So 12 squared equals x squared plus x squared. So 144 equals 2x squared. What do you do to each side? Divide by 2. X squared equals 72. Take the square root. 8 point what? 8.48. Round to the nearest meter. Meter. Is it 8 or 9? 8. 8. Because it's less than 50, so you round down. Okay. 4, 6, 7, is that a right triangle?
Yes.
Is that Pythagorean triple?
Yes.
No. So you'd have to look at it. You'd have to take 7 squared and compare it to 4 squared plus 6 squared. 49 compared to 16 plus 36. 49. And this is 52. So if it's less than, it's not a right triangle, it's an acute triangle. All right? And the last one, okay? You have to find a Pythagorean triple with 20 and 21 in it. So either x is smaller than 20 and 21, and this is A and B and C, or 20 and 21 are the small sides, and C or x is the hypotenuse. So let's try them both. Okay? Is 21 squared, compare it to x squared plus 20 squared. So 441, compare it to x squared plus 400. X squared equals 41. Take the square root. Is that a whole number? No. So let's try this one. 20 squared plus 21 squared, compare it to x squared. This is 400. This is 441. Compare it to x squared. This is 841. Compare it to x squared. If we take the square root, does 841 have a square root? 29. So this is a Pythagorean triple if the missing number is 29. So that one takes a little more work, but you have enough time to get all 15 problems done. There's 25 minutes left. You have enough time to get everything done. So let's get it done. Gabe did know what we were doing for a little bit, but then